Well, good afternoon, good evening, good night, good morning. I suppose depends where you are. Welcome to another episode of Serverless Office Hours, streaming live on the AWS Twitch channel, on YouTube Serverless Land, and also via LinkedIn Live. My name is Julian Wood. I'm a developer advocate for serverless here at AWS, and I'm joined by the one and only, and there really can only be one and only, worldwide tech leader for serverless here at AWS, Josh Kahn. How are you doing, Josh?
Good, Julian. How are you?
Excellent. I'm good. It's been a slightly frazzled day getting here on time. I'm in the office. We're doing the London Summit tomorrow, which is exciting, but a bit of back and forth across London, as you do, but those are first world problems. So yeah, tell us, you worldwide tech lead at for serverless at AWS. That sounds like an important title, and I know you're an important person. So what does that entail on a day-to-day basis?
I don't know if anyone would agree with that, at least anyone that lives in my house. But yeah, so I'm the worldwide tech leader for AWS around serverless. So I'm kind of like a specialist solutions architect. I focus on services like Lambda and API gateways, step functions, EventBridge, etc. But I'm also responsible for our internal community of practice around serverless. So we have over 1,000 people here at AWS who really enjoy working with these technologies, and they may not be assigned to work with them full time or be a specialist SA, but they like to help their customers. So we've got over 1,000 people now that do that.
Yeah, no, that's an amazing community all across AWS who sort of, partly work time and a lot of their own time, just put a huge amount of effort into learning all of our serverless technologies so they can help everybody else to be able to put it all together. So before we talk to Josh in depth about today, let's look back at the last week of serverless. Well, last week was a super cool show. We had Dirk and Christian who were talking about different serverless messaging services and things like SQS and SNS, but not just what the services do, but more particularly how they could connect together and thinking of architecture patterns to use them effectively. So that is on our Serverless Land YouTube channel, along with all previous other Serverless Office Hours episodes. So yeah, quite a backlog of interesting things that are there. What's new in the world of serverless hasn't been so much over the past week. Just over a week ago, step functions, if you're doing in the media world, a lot of people are using AWS Elemental Media Convert, so an integration with step functions for that. And then also the second one down is an interesting one because even though it's a CloudFront release, it actually helps with security for Lambda function URLs. So Lambda function URLs, if you're unaware, has no authentication, so it can be open on the internet, or using IAMauth, which is really cool. But if you're using IAMauth, how to use it sort of open on the internet in a way? And CloudFront allows you to configure CloudFront to be able to do that SIG-V for signature. And so you can have cool CloudFront hosted secure Lambda function URLs using IAM. Best of both worlds in my book, so that's really good. The next one up, blog post, in case you missed it, is just our first quarter of the year and all the serverless releases that have come out, and blog posts and videos and all the kind of interesting things to learn all things about serverless. In terms of things coming up, I mentioned the London Summit. That is tomorrow. I am doing a talk with Michelle Chisholm. So yeah, I think they're going to be 18,000 people there. So that's going to be fun. And I'm on the big stage. So if you're there, it'd be love to see you. I won't be able to see you because the lights are bright, but I'll wave at you and you'll come and say afterwards. And yeah, lots of other summits coming up. I think there are also one or two being added to this list. So keep up to date at the web link on the page. But yeah, summits are great. Lots of free content. Some sort of really big things being showcased at a summit. So yeah, really think local to you, which is really cool. Also, go to EDA Day London. I know Josh and I are both speaking at that. So that is on the 14th of May in CodeNode. It's literally around the corner from where I am. Event-Driven Architectures Day, if you're wondering what that EDA stand for. This was done about 18 months ago. Fantastic content, all talking about integrations, event-driven architectures, doing the best with a whole lot of different services, and really listening and hearing from companies that have been able to implement EDA and made their organizations fly. That's the past week. We are talking this week about real-time web and mobile backends. Now, Josh, that sounds a bit of a mouthful, and apologies because I put that title together. But real-time mobile backends, I know there's a lot going in here. So what are we talking about today?
Well, we're talking about real-time web and mobile backends. No, it's actually kind of a preview of a little bit of what I'm going to be talking about at EDA Day. But how you can use different AWS services. I think we'll primarily focus on AppSync a bit to actually kind of take those events, things that are happening on the back end or the server side, if you will, and share them or keep up to date on whatever the front end or client application might be. So a lot of times it's mobile apps these days, something on iOS or Android. Frankly, it's a lot easier to build a web application for most people. So we'll tend to play in that JavaScript world if we pull up any code.
Okay, so yeah, I mean, this is a really common use case, particularly for serverless, where you have some front end code hosted anywhere on probably the world's biggest website hosting service, which is called S3. And then you've got your API calls that can talk to the backend. And, I know what we're sort of talking about today, but a lot of people are running, synchronous APIs and doing a whole kind of thing. So I know we are talking about, the front end being on the front end, the back end, and, ideally you want that all asynchronous and they all sort of fit together. But really that was hard, that was complicated, it was really slow. Yeah, tell us what we should be thinking about as a mental model of putting the pieces together.
Yeah, so a lot of times, everything on the front end tends to be event driven by its nature, right?
Yeah.
Like if you click on a link or scroll on a page, even if you linger for too long, right? Like that might be a signal that somebody wants to pick up that you've stopped to look at that particular item on the page. So all of that is very much event driven on the front end, but in order to load data, you'd click a button and it would run off to the server and it would be some synchronous event. If you're building a mobile application, right, you might have to, like on iOS and Swift, you'd have to have it, kind of run that request on not the main thread, right? So you didn't lock up the whole device. So what we've been thinking about is how can you use technologies like WebSockets and other means to keep up to date when something changes on the back end. Maybe your pizza goes out for delivery, or a package is shipped, or a sports score changes. So that's really what we're focusing on, and some of the different ways that you can make that happen, including a really nice integration between AppSync, if I can get that out of my mouth, and EventBridge.
Okay, cool. And I actually like that mental model you mentioned about lots of the front end being event driven already, because I know, some people I talk to and they sort of trying to scratch their head, and the JavaScript developers scratching their head about, what does EDA mean? And I say, well, if you think of the JavaScript event loop, in a way that is event driven architectures, you have a loop that, okay, it's continuous, but, an action and a reaction and it goes on the loop. So I think it's really nice, this model of front end developers are in a way sometimes able to sort of see the potential of using event driven architectures on the back end, because this is slightly different terminology. That's what they're actually building already on the front end.
I mean, something happens and you want to respond to it, right? That's how some of our colleagues describe EDA in its simplest terms, right?
Yeah.
Something happened, I want to do something about it.
Cool, excellent. And don't forget, we are live here on Serverless Office Hours, so let us know where you're from. Any questions, any comments, happy to hear from you. We've already got Daniel Habib, who is a well-known translator and worker in over here, and of course he needs to say that Josh Kahn is the boss. So welcome Daniel again, and Tata Shebe from South Africa. Thank you, Tata. I'm originally from South Africa, so always nice to hear people from the previous country. So Josh, where should we kick off? What would you like to show or explain?
I mean, we could start with a little bit of AppSync and EventBridge. Really kind of a fun integration that launched, I guess, a few months ago now already, but towards the beginning of the year. But we could try our hands at a live demo and just see how it goes.
I like the bravery. Love it.
Always bold, right? Otherwise, we have stuff we can fall back to.
Plan B, I like it. Cool. Okay, I can see your screen coming up. Let me get on that.
Make it a little bigger.
Excellent. Yep.
All right.
So we see the AppSync console.
Yeah, so I quickly threw something together in AppSync. So if you're not familiar with AppSync, interestingly, like as I talk to a lot of people around the community, they're highly familiar with services like API Gateway, which of course has been around for a long time. AppSync's been around for quite a while as well, but it's a managed GraphQL service primarily. I like AppSync. It's one of my favorite services to work with, not just because I got to actually play with the original alpha that the team built many years ago now, but it just works really well for these types of use cases. So I built very quickly, like in the wizard, just kind of a to-do management type app. You start in GraphQL, you start with a schema, and this is a pretty bold schema, but really the heart of it is this to-do item, right? So we define a type, much like we would in JavaScript, or creating a class. You define the shape. An ID is a string, and the exclamation point means that's required, right? That value has to be there. The other values are optional. And essentially what we can do with AppSync is go define this schema. A lot of this, by the way, is just kind of boilerplate that it generates. And then we can go create 3 different types of operations. There's mutations, right, which change data, create, update, delete type things, queries, get and list. And then subscriptions are actually the most interesting to us today, right? So a subscription is, hey, something changed. Generally, it's a little bit of data. But what I really like about AppSync is it gives you some of this filtering and the ability to kind of narrow in for free. So if you, for example, we're building like a delivery app, right? We don't want Julian to see a status update on every delivery that's out there. But we do want you to see just the updates on your order, right? And you could kind of modify the parameters here so that you only specify, let me know when the order changes for this particular order. So, and with AppSync, like one kind of trick to the trade is that every subscription has to be paired with a mutation. So you can attach subscriptions to any data source, but you have to mutate that data, even if you're just kind of doing a faux or a fake mutation, to get AppSync to send out that payload saying, hey, that subscription happened.
So in terms of the AppSync part, I mean, we had a question from Alpa Codes. Thanks for joining us via Twitch. A regular watcher, which is cool to see. So how do you keep the GraphQL and DB schemas in sync? I mean, we can come back to that later if you want, but yeah, that was just a question we had.
Yeah, so that's a good question. Yeah, I mean, it kind of comes down, for me personally, and there's probably better enterprise practices out there. It's really just about being, kind of keeping an eye on what my data model looks like across the board and having change control. At least when you get started with AppSync, they have some nice adapters for Aurora and for DynamoDB. I actually use the DynamoDB one here so that I could quickly create a DynamoDB table to support this API in the background. But it is kind of, again, keeping it in line with best practices.
Yeah, that's what I've heard as well, that people who have been doing this, one of the powers of AppSync is that you can create the data model and then in a way abstract your database schema behind the scenes, because you can do all the, not transformations, but you understand that you can gather data from a number of different places. And although that is powerful, it doesn't mean you can do what the heck you like with the data on the that's actually in the backing store. So yeah, some governance and process to keep those in sync will probably help a long way. Some documentation, imagine that.
Yeah. And even things like understanding your event schemas are important here, right? Because even though there is a schema and it's a little more fixed than a REST API, you do have to understand the schema and what's expected.
Yeah.
So I won't spend too much more time on AppSync. The other kind of important aspect of this, though, is these resolvers or mapping templates. So these used to be only velocity templates, VTL, which nobody loves VTL. So AppSync released over a year ago now, I think, support for, it's a minimal set of JavaScript, right? You can't do everything that you would normally do in JavaScript in these, but you can now write these templates in JavaScript. They have some nice utility packages here. It's using like a put command for DynamoDB that, makes it pretty simple to go build this out. But basically, it's just a little JavaScript to go collect some of the arguments from the query in this case, or I'm sorry, the mutation. And then it goes and performs a DynamoDB put item operation, right? So these, at first you look at them and you're like, oh, what's going on? But there is pretty good boilerplate and template out there as well for you to get started. So that's the AppSync side of things. What I thought would be cool is flipping over to EventBridge real quick, and I can show some of the integration between EventBridge and AppSync and how you can have EventBridge actually publish messages directly to AppSync, the AppSync API as a target. That's the new feature that was created. You can also, by the way, before I jump away from here, you can actually target AWS services instead of just a DynamoDB table as your data source. So you could have an AppSync, I guess a mutation would probably make the most sense, that publishes a message directly to EventBridge or directly to SQS or kicks off a step function state machine. So it's pretty powerful, much like API Gateway, where you can do a direct invoke to other AWS services. You can do that here as well.
Yeah, so direct integration like API Gateway, not quite the same as the step functions SDK integrations, but also, it's a similar model. At least you can connect directly without having to have a Lambda function resolver in the middle.
Yeah, you definitely you lack the kind of nice drag and drop that Step Functions has these days in Workshop Studio. I've published a couple blogs on how to build some of these direct integrations, because you do have to treat them a little bit more as raw, like HTTP endpoints, but you can be done. So I'll hop over to EventBridge, and this is just, I created a to-do event bus, and we're kind of going to build this little demo on the fly to some degree. So we can create a new rule in EventBridge, and
you're still on the AppSync console, by the way. If
I'm still on the AppSync console. That is my fault. I'm sorry.
No worries.
This is what happens when you.
As you can see, we're live. We're not fudging this with doing recorded demos. Really.
Yeah, I mean that would be.
While we're here, yeah. Danny, hello from Seattle, and we've got. We also had bazookas from Tunisia. Cool. We've got a really international stream this week. Love it. And of course, local. Pawan, thank you for joining us from West Midlands in the UK. Oh, other screen. I'm not paying attention. There we go.
There we go.
Yeah,
all right. So again, with a to-do app, I don't know that you'd necessarily publish all your to-dos through an event bus, but oh well. So we can create a new rule. We're not going to worry about like a sample event or whatnot. But we'll create just kind of a custom pattern here. And maybe we want something like, source is to-do live demos. And maybe the detail type, actually, does that need to, we'll see if that works. Something like new to do, right, Julian? That should work.
Yeah, I'm holding thumbs.
Yeah, all right. So that's just kind of our typical EventBridge rule creation. What's nice about the integration between EventBridge and AppSync is once I get to the target, I can select AWS service, select the target type, and pick AppSync from the drop-down list, right? And you do need to have IAM auth enabled for your AppSync API. So much like API Gateway, there are multiple different types of auth providers for AppSync, IAM, OIDC, Cognito. You can also do a Lambda authorizer. What is different about AppSync from API Gateway, though, is that you can actually have multiple authorizers attached to a given type or attached to a different attached to the same operation. So there's actually times where I'll have both an IAM authorizer so that EventBridge can invoke that operation, and I have like a Cognito authorizer so that somebody who's logged into a React application on the front end can use it.
That's useful.
It is a useful little thing when you think about it. So here it's automatically gone and grabbed the list of APIs that I have in AppSync in this region. So I'll pick the to-do API, and then it goes and specifies this GraphQL endpoint ARN. There's a couple of different ARNs for AppSync, and you have to make sure that you grab the GraphQL endpoint, not the API endpoint. Otherwise, things won't work. I learned that the hard way when this first came out.
That sounded like the long way as well.
Yes, I also found a bug, but that happens. An event, the teams fix them pretty quickly. So then AppSync also goes and looks at introspects your schema. Introspection is actually the word, and it looks for the different types of mutation operations that exist. So here are those 3 mutations that we had available in our schema: create, delete, and update. This rule was around a new to-do, so we'll pick create. And you can see, because we can that GraphQL schema specifies so much information about how to use the API, EventBridge can be really, really smart, and it can help wire together this integration pretty quickly. So in AppSync, in GraphQL generally, the way you specify your query, you can list the different data fields that you want returned as part of your query. So you can imagine if you're building like a mobile front end, like for a mobile application, maybe you want a different set of information. Maybe like on the main listing page of our to-dos, we don't care so much about the description, right? We want an ID, a name, and when it's due, right? That's the only information we want. So we can actually specify that in the mutation. I'll get to where that comes in just a moment. But essentially, the client has some control over what information it would like back. And the EventBridge console here has actually gone and created the exact GraphQL mutation call or whatever you want to call it that we would need. You can also use EventBridge input transformers, right? So if I click here, there's a whole wizard that you can actually walk through. I don't know that we'll get all of this working today just quickly on the fly, but you can actually specify, in your detail path, we could have something like, the name is coming from $.detail.name, for example, right? We could also add.
So you can use the input transformers to sort of prettify the incoming EventBridge payload, so it can invoke that, or it can run that AppSync mutation without having to do crazy stuff on the AppSync side. You can do this transformation on the EventBridge side.
Correct. So you are limited by what the input transformers allow you to do.
Yeah.
But I think it's something along those lines, right?
Yep.
Like you can kind of take care of that in the input transformer and kind of get the data set up for what AppSync expects it to do. You do need to have an execution role, right? Because again, EventBridge needs permission to perform the GraphQL operation on the AppSync endpoint. And there are some other additional settings that you can set up, much like with any other EventBridge rule, right? Retry policies, dead letter queues, etc. So I'll just hit next. Everything is in theory set up, and in theory, there we go. So it did go create that new rule. Now, one thing that is really nice that I just want to go back to is if I click on the rule, EventBridge, and this was super helpful to me as somebody first working with this feature, EventBridge actually has added a little CloudFormation template, creation capability, right? So if I click YAML here, it's actually going to give me the CloudFormation template for this EventBridge rule, including all of the GraphQL stuff that I need to make this happen. So this was nice. Extremely useful because, in my case, the docs weren't real specific about this GraphQL operation, for example, at the time. And I was able to kind of figure out what needed to happen. So that's essentially the setup. If all worked well, we could give it a go and just see what happens. I'm sure something is likely to not go right, but we could just send an event here. The to-do event bus. New to-do. This is bravery, Julian, isn't it?
Was it new dash to-do? It may have been.
Yeah, it could have been. This is bravery.
Oh, we'll do it.
We'll see what happens. So if we send that through. All right, I let's see. Yeah. So somewhere along the lines, it doesn't seem to have made it. But we can start doing things like tracking back through some of the AppSync CloudWatch logs, etc., to try to see where the breakdown occurred. But again, this is a really nice feature. For example, like if you're building some sort of e-commerce system and you want to just be able to publish these events directly to your endpoints, you can do that and use it to update your users.
One thing I'm sort of mentally struggling with is I think of AppSync and GraphQL as something that's going to mutate data, and you're going to get CRUD operations to various data sources behind the scenes, and it's got a nice schema, and it's going to abstract that, and you've got this query, clever query stuff behind it. I don't quite get in my head how when you publish something from EventBridge, it goes to AppSync as a sort of push operation. How does that sort of flow through the system? I don't see how that updates the subscriptions, or am I missing part of the story with AppSync and GraphQL.
So like, how do I get from EventBridge is pushing some information to, yep,
So
getting
AppSync,
across,
and that's,
yeah.
because it's not quite a data source that it's querying. It's, yeah, just seems interesting. Something I realize I don't know.
Yeah, so I'll just pop here. I've got a few slides that we can try to use here. We'll see if one of them, no, that's only looking for Chrome. There we go. So this is the true preview, right, of what we're going to be talking about at EDA Day, frankly. But with EventBridge, kind of on the right-hand side here, as that we've configured that rule to essentially deliver the payload to AppSync, and AppSync for each operation, we're going to define the data source, right? And actually, you can have multiple data sources be updated at a time using something called pipeline resolvers that I won't get into. But we're just going to update this DynamoDB table, right, which is our data source for this, create to do operation. So what's happening here is we're actually performing the mutation operation ourselves. And the resolver, if we go look at that create to do resolver again, remember it had a put item operation?
Yeah.
So AppSync is actually doing that work for us in this case.
Okay, so it's like having one client is writing to the database via AppSync, and then the front end is reading from the database in AppSync. It's not as though the one client is writing and directly to the other client. It's sort of flowing through AppSync, but it's actually being persisted in DynamoDB. That was the missing link I got. That actually makes complete sense. I'm like, wow, why did I not get that? So.
And what's really cool, so this pattern is pretty simple looking, right? Like, because we're using AppSync not just to kind of update the persistent store for our little application here, but we also, when we perform that mutation, that's what basically triggers AppSync to send this subscription as well, right? So that's the important bit. Now, what's really cool is this may not be DynamoDB, right? Yeah. This might be Neptune, Amazon Neptune, or it could be QLDB, right? Which is another one I've done. As long as there's a mutation operation performed that's associated with that subscription, you can publish that change out to the client. So don't, as you're building applications, you don't need to limit yourself just to the built-in integrations that AppSync has. And one of the ways to do that is actually to, this becomes a little bit more complicated, right? But we can also tie this into DynamoDB streams, for example. So here, this pattern is a little bit different, but maybe a little more familiar. Essentially what we have is we have an event bus again, but the rule is actually now invoking a Lambda function. That Lambda function is going to make some change to the data, presumably, and it's now, instead of AppSync, it's going to go write that data to our Dynamo table. And now our Dynamo stream is going to, see those changes. And we can do some nice stuff here, as you probably know, like filtering to only look for certain types of events. Maybe we only want inserts or inserts of a particular type. We can have another Lambda function. And again, there might be other ways to do this, but this is really simple, right? I have another Lambda function that basically takes that change data, and then I want to publish it to AppSync, or I'm sorry, I really want to publish it, the change to my client, which is some remote device somewhere. So the way to make this happen, and I've written a couple blog posts on this, and we call this like an out-of-band update type pattern. But AppSync has this special data source called none. And basically that means we're not going to update any data. We're just going to pass the input as output, right? It kind of is just kind of a pass-through. It doesn't change anything. So this pattern, right, you can insert anything into this DynamoDB corner, right? Neptune, for example, supports streams now. It would basically be kind of almost a drop-in replacement if you wanted a graph database. So this is another way to approach this, where again, we've got some changes happening, we pick those up, and then we publish those out to our subscribers through this none data source, which is basically, again, just a pass-through.
Okay. So the first one is for a simple mutation. You don't between EventBridge and say DynamoDB and AppSync, you don't need to do much transformation or anything like that. Or if you can go, if that doesn't work for you, this is a bit more of a additional featured option where you're basically using the native features of DynamoDB, can read from the stream, and then you can do your filtering or you can do anything over there and have sort of rich functionality. And then you're using AppSync as a pass-through to still send that notification out to your clients.
And again, like with the EventBridge, the EventBridge only pattern, you can only do what the input transformer allows you to do, right? Which is kind of some string manipulation type stuff. With this other one, it does give you a little bit more flexibility because you have the power of Lambda essentially available to you. So a couple different ways that you can go about doing those types of updates. I personally like AppSync just because it gives me the ability to have kind of give me the initial load of data and then just send me the little updates over time, all in one package, in one well-defined schema. There are some other approaches that I'm sure folks are at least a little familiar with that you can take advantage of here as well.
Okay. Yeah, no, that is certainly interesting. And I suppose then also from your front end, you're not thinking about different ways that you're going to consume that kind of data. Everything's just talking to AppSync, and you have your sort of connection between your front and back end in terms of the schema and what you're going to return in one place.
Exactly. So this is kind of an example using AWS Amplify. So Amplify is a set of front end libraries that you can use to integrate with different AWS services. This is the JavaScript version. Amplify also has a bunch of other capabilities. This is just kind of one thing under that brand name. But here we're just showing how you can, in your React application, we can subscribe to changes, as kind of a broadcast, or we can filter down to like a specific order, right? So you can actually get very fine-grained with these subscriptions. And AppSync also has some what they call enhanced filtering, where you can even do more kind of on the server side, more filtering. In this case, I'm just kind of specifying different parameters.
Okay, so then for people to know, that broadcast subscription would be maybe a notification that is then sent to all of your customers, and the point-to-point would be an update on your individual order, or a status update to an individual device or something.
Yeah, exactly. Right. So I'm telling everybody that a new order has come in versus just updating Julian on his pizza status.
Cool. Definitely no pineapple.
Yes, we know everybody stands on pineapple these days, I think.
So how should people think about then, because there are obviously multiple ways that you can notify clients. There's the whole WebSockets model, and we can do WebSockets via API Gateway, and we can do WebSockets via IoT Core, which is also quite a nifty. It's only a few lines of code to do that. Is AppSync GraphQL using WebSockets under the hood, or is that a completely separate thing?
No, it uses WebSockets under the hood.
Okay.
So kind of under the covers, what happens, the operational side is similar, right? From a JavaScript or Swift perspective, you send across this subscription little tidbit of GraphQL, and what comes back from the server is a secure WebSocket URI, and then basically whatever library you're using, here I'm using Amplify, opens up a WebSocket connection. So deep down under the covers, similar. I personally, again, I find some benefits to this approach, but at EDA Day, I'm also going to be talking about how you can do this with API Gateway and IoT Core, which is, Julian said, are two other ways to make this happen. And then, of course, you could do more of a polling type approach, which is a little bit more expensive. Just the client, do you have new data for me? Do you have new data for me?
Yeah.
And as a parent, like, are we there yet? Not exactly my preferred approach.
Yeah. No, definitely. No, yeah, I love that. Love that explanation of the kid in the backseat of the car. Are we there? Are we there? Are we there? We all want to stop that.
Exactly.
So these different sort of WebSocket approaches. In fact, Danny, thanks for asking a question. It says, do clients have to be 100% of the time connected to AppSync to receive the response, or is it AppSync that sends the notification as a request? And I know this is, sometimes when you've got flaky network connections, or using a mobile app or that kind of thing, and you go into a train or into a tunnel, does AppSync handle this reconnectivity and just send the messages, or does your front end need to reconnect?
There's some interplay between the client and the server at that point,
Okay.
right? Because you need to have probably some persistence on the client to know this is the last set of data I got or the last time I connected. So in the AppSync world, there is a partnership with Amplify. Again, kind of that front end set of libraries. Amplify has a component called Data Store that you can use to, sync up.
Local cache, yeah.
Yeah, local cache. Yeah, so basically, maybe it's got like a SQLite type database, depending on the device, and it basically keeps track of what has changed in the last time that it updated. So for my simple React examples, yes, the client needs to be attached to that WebSocket connection. If you lose it, I didn't build enough to like keep that local cache, but it is possible. Now, another one of the patterns that we can talk about, or we won't talk about here necessarily, but push notifications, which are a little bit different, right? So push notifications rely on Apple or Google or Firefox to do push notifications into the Firefox browser to kind of send those notifications from the server. And then the connection state is really between the client device and the broader internet, as opposed to just AppSync or whatever API that you're hosting. That is a little bit different pattern, and there's different kind of moving parts there.
Okay, so I presume then the Amplify library does probably have a bit more robust, reconnectivity kind of stuff that you've got less to worry about. Because I know, on the work I've done before with IoT Core, that's pretty robust. You can, disconnect when you reconnect again. Those messages are just queued up and get sent through. That I don't know where they're buffered or somewhere they're buffered, but it just magically seems to work.
Yeah, a little bit of magic with IoT Core and things and shadows and whatnot. But yeah, Amplify Data Store is the name of the component that would live on the front end, and it helps manage some of that. You do need to add, for example, a couple of extra fields to your Dynamo table if that's your data source, so that it can keep track of like, this is the last time this record was touched.
Okay. Yeah, and I know that Amplify Data Store, it's used for a cache, but it's not necessarily just an AppSync kind of thing. It can be used for a whole bunch of different sending data. You can cache it locally, batch things up, and then send it up into the cloud. So that's useful.
Yeah, and we're kind of getting into that world of full stack / front end developers now, right? You need to think a little bit about what's the connectivity, what capabilities exist on both sides of the spectrum now, right? Because you're automatically introducing some partition the moment you have a client device. Yeah,
excellent. So yeah, what else would you like to tell us about the sort of brave world? Because I'm thinking here, I've got the sort of front end done and connected, and I'm now able to change data in some different complete part of my system, and then via EventBridge to trigger a rule that's just going to automatically update my front end. Yeah, that sounds magical. What else should we be thinking about?
Yeah, much like other things in the event-driven space, right? Schema matters, right? What that event payload looks like matters. Although, again, using GraphQL does help. You have a schema, so it has an expectation of what the shape of that data will look like. I think the other thing to keep in mind is as you're building things out, taking advantages of tools in the AWS ecosystem like CloudWatch and X-Ray. Dead letter queues and SQS can be your friend in terms of understanding what's going on in the system, and if it's not working exactly the way you would expect it to. Even I sometimes run into as I'm wiring this stuff up, like how even on our quick little demo, right? Like the message disappeared, so I would have to do some troubleshooting to see exactly what happened. In my case, it's more likely than not a spelling error somewhere, quite honestly.
So yeah, just talking about that sort of troubleshooting observability in that kind of example, where you're looking at. You mentioned CloudWatch. Does X-Ray even play into this? What would sort of your troubleshooting steps? Because all these integrations via AppSync and a lot of magic going on. The end-to-end pathway. How does one think about monitoring and troubleshooting?
So AppSync has built-in support for X-Ray. It also will log logs and metrics to CloudWatch just out of the box, as long as it has permission to do so, right? Much like other services. I tend to start digging into some of the CloudWatch logs. With this particular case, you would see, there could be some trace kind of as a client calling, the client being EventBridge in this case, not to be confusing, calling AppSync, right? So you would see some of that. And then the AppSync trace would also include whatever time is spent writing to Dynamo in this case, right? So you would actually see that subsegment in your X-ray trace as well.
Oh, okay. Okay. And then I presume there are also a whole lot of CloudWatch metrics that you can do to, figure out if things are breaking or going wrong.
Yeah, so there are a bunch of other metrics. One of the nice utilities, CloudWatch Logs Insights has a very, very long name, but it's actually one of my favorite features in CloudWatch Logs because it allows you to dive into some of the log messages, understand some of the data. And actually AppSync also has much like Lambda, has kind of a bunch of pre-baked Logs Insights queries that you can use, including some that will break down like latency by operation or resolver, right? So you can actually start to get a feel for how are these getting used, how often is create to do getting called versus delete to do, how long does each one take?
Okay, yeah.
There's quite a bit there that you can get into over time operationally.
Okay. And then, lots of people, I think, are hopefully understanding the EDA concepts, and they're understanding that you can't do everything as a synchronous call. That's what they've been doing via REST APIs, and lots of work we've been doing as well to encourage people to, have as little sync as you can. Maybe on the front end, or if you're putting something somewhere, to have a very quick response and persist it somewhere, and then have everything sort of async on the back end. This sort of follows that model, but sort of I wouldn't say breaks it really, but sort of is a kind of different way to think about it, because in a way you're using an entirely async model on the back end to push things to the front end. So yeah, how should people think who've been doing a fully synchronous way and they sort of getting onto the EDA bandwagon and thinking, okay, I need to do sync and async? Is it a mental model shift, or just different services and different things to think about, specifically GraphQL?
It's a different way to think about things. This pattern and this type of discussion has actually become fairly prominent for us with this big explosion of generative AI, right? And I don't want to, say Gen AI all the time, but I actually had a customer call this morning where the customer had built an integration with a Gen AI service, and it involved their pattern involved like calling OpenSearch to get some embeddings. And then they would call the Gen AI service. And once in a while, the request would take something like 50 plus seconds. So when you have a request that takes that long, you might hit a timeout in a synchronous service, like API Gateway. AppSync also has a 30-second timeout for queries.
Okay.
So my recommendation has always been like this type of subscription pattern can be really helpful, whether it's 31 seconds or 3 minutes potentially before the response comes back, because you don't have the client just waiting around and potentially frozen. It's ready to handle that event whenever it comes back, because as you said, Julian, it's totally asynchronous, and the client is now kind of part of that asynchronous party when you take this approach.
Okay, yeah, that's actually super interesting to have that sort of push-based mechanism from AppSync and GraphQL, but then not be limited by that by the 30 seconds for API Gateway, or also for AppSync. That's interesting, because I think that's a really good. I mean, even when I'm using my mobile phone and you have different apps, and if you do have to wait for something, that is painful, but you want to be able to carry on and just get a notification or a pop-up somewhere to go, file uploaded, or new data, or updated scores, for example, and you can then go and refresh that.
Another spot that we've seen customers use this type of approach is with something like an Athena query, right? So if you're using Amazon Athena to query data in like S3, the job goes off and runs totally asynchronously, and then it just delivers the results back to an S3 bucket. So you can imagine actually wiring that together, grabbing the S3 event that gets fired off when the object ends up in the bucket, and then using that subscription pattern to notify the client, right? So then they're not constantly clicking pull or checking the S3 bucket to see if the data is there, if they even have access to it. So it's another approach that's a little different than a different use case, a little different than like waiting for order status, but here like more of a data analytics type use case.
Yeah. Excellent. And yeah, I presume lots of other use cases, even if you think of the canonical e-commerce store of, even doing something and getting a notification after the fact. This is front-end notifications, but it could be any notification to, various kind of systems, or, an updated price in a cart, or, any kind of, and I suppose errors as well. I think this also seems quite an efficient way. If you've got any back-end service issues that you need to pass on to the front end, it's just another notification.
Exactly, right? So you're able to push things out. And again, there's different mechanisms, but in this case, if we've got something, the application up and running, this WebSocket kind of driven approach under the covers works really well.
Yeah. Another thing I was thinking about when we often talk to people about synchronous and asynchronous is people go, oh yes, but the asynchronous is slow. Like, I want quick updates to my front end. As soon as if I'm doing all synchronous calls, I've got full control over that. As soon as I, do the separation of the quick sync and then the slow async, it's just painful slow, and it's a poor customer experience. What are your sort of thoughts on that?
Yeah, I mean, you can still do as much as you want to try to make the initial response as fast as possible, right? Like, you talked, Julian, earlier, I think at the beginning about, kind of that persistence first pattern, where maybe we have an API call that writes to an SQS queue, and then the work goes and happens later. But the response back to the client is, hey, we've got the message, and that comes through immediately. You can actually follow a similar pattern here. The data may not be available immediately, but it could be in the future. Now, the AppSync based approach that we focus a lot on today doesn't support like response streaming, but that is something that you could look into with other types of connectivity for the client, as well as another means to get that first byte back as quickly as possible.
Yeah, and I also think the whole async story is actually getting sort of moot. Even EventBridge has drastically reduced its latency internally. Isn't it? I think it's under 100 milliseconds now, or something. Yeah, don't quote me on that, Nick. You're gonna.
Yeah.
But it's really fast, and that's also, I was playing slightly devil's advocate, because I know that when we're thinking about some of these integrations, that if you can send a synchronous message, it is going to do something, cause an EventBridge rule to fire, which is going to fire it to AppSync, and it gets, all of that happens in under 200 milliseconds. Like seriously, that you're not, that's blink of an eye kind of stuff. You're not really being held back. So I think that's why it was a bit tongue in cheek and a bit of devil's advocate to say that actually you can still build these very effective synchronous and then a whole lot of async on the background, and to be able to then push things to the front end really quickly. And also, I know, even internally, the EventBridge team and other teams are working really hard to reduce that latency even further. So, it could by the time you've also, even spun up a Lambda function, not that cold start is necessarily slow, but you're not necessarily getting even now and maybe into the future, you're not going to get a big difference necessarily in the response time.
I mean, like you said, you can be very responsive, and there's also patterns that we see on the client side now where you start, it's a little bit more pleasing of an experience as you're waiting. But yeah, I wouldn't tie myself to synchronous, because again, like, especially in this world where we might have longer running actions, like something like Gen AI. It might generally take 10 seconds, but there's some long tail latency out there where it is taking more than 30 or 40 seconds. And that's just a poor customer experience if your client's just sitting there spinning and waiting.
Yeah, and definitely, I think, and Ryan Cormack, Ryan's in London. Thanks for joining us again via YouTube. So yeah, optimizing for milliseconds over async and ignoring a monster SQL query that is really slowing the app down. Exactly. So all these things we talk about the trade-offs. So yeah, thank you. But I think that is the kind of thing. I mean, as soon as you are using already GraphQL, you're already having that sort of data aggregation at your scheme and your GraphQL level, rather than having monster SQL queries that are doing joins across multiple databases and causing a whole bunch of havoc. So
yeah, you're able to load things across different data sources as well, right? So you can create kind of a singular API or endpoint that can pull together data from many different data sources, aggregate it, and again, the client can kind of pick and choose what they want to have access to. One other thing that I wanted to mention, just for anybody who's off and playing with this stuff later today, because I'm sure that's what everyone's going to rush to do immediately when we're done, is when you are working with AppSync, one of the things that I often tripped over was when you do a mutation, right? We looked at the selection set of data in the EventBridge console, right? We picked kind of those 3 fields that we wanted to come back from the mutation. But anyone that's subscribing to that, new to do subscription or new to do update will also only have access to whatever that set of fields are. So I generally, when I do a mutation through something like EventBridge, I try to include all of the fields that are available for that return type so that subscribers can choose whatever they want and they're not limited by what my backend mutation is doing. And that comment might make more sense as you start to work with the technology, because it's kind of one of these little cases where you're trying to figure out, why is this data null? And it's really because it was something kind of happening over there offline.
Okay. And I suppose that comes into general GraphQL best practices of how you manage your schemas and what data it is in there, because also part of one of the powers of GraphQL is you're doing a single fetch, which is grabbing everything, putting it all together and returning it back to your client. So in a way, you don't want to be limiting the information that can back, well, unnecessarily limiting the data that potentially could be useful to your client.
Yeah, I mean, it's a byproduct of how the system works too, right? That some of that data may not be available, but I've tripped over it more times than I can count, even with some projects I was building just the other day.
Okay, oh, excellent. So yeah, just some sort of questions that had come in. Alpa Codes, thanks again. Yeah, this was back when we were talking when you were generating the GraphQL data, and said, assuming a relational backend, does GraphQL generate a select SQL based on the selection set? Alpa Codes, my brain is trying to. Josh, do we need more info? Or
I think I know what you're getting at. Okay. So when you build the mapping template or the resolver, you could hard code the SQL statement, the SQL selection statement, or with the way AppSync works, at least, and Apollo and others might be different. But with AppSync, your resolver has access to something called context, and that context will actually list the set of fields that the client is asking for. So you could actually do just kind of a generic, give me all the fields back from my relational database, or based on your GraphQL query, only give me the fields that I'm asking for. So hopefully that answers the question. But you can dynamically create that selection against your relational database if you want to.
Okay, thanks. And yeah, Daniel again, GraphQL can connect several data sources and simplify the API for the mobile and web. How to avoid have a GraphQL service becoming a monolith in a microservice architecture?
So AppSync, again, we'll just kind of focus on that, but AppSync supports this idea of merged APIs. So the idea is that you can have multiple teams or multiple business units all contributing to the same GraphQL API, and they do it by creating kind of subunits that get merged together. So that would be my best answer, is kind of breaking apart the monolithic API as much as you can into these separate APIs that then eventually get merged together. API Gateway has a similar concept using like multi-level base path mapping, for example.
Yeah. Excellent. Yeah, but good point. You don't want to land up having many microservices that all aggregate to one big thing that's then a pain to keep up to date. And yeah, Alpacos did come back about it's hard to debug async workflows when a workflow gets stuck waiting for an event that will never come. For example, if you forget to set a timeout or heartbeat in step functions. Yeah, absolutely. Yeah, I mean, definitely, I think we know some of these things are going to be hard and challenging. One of the things from the EventBridge side that some people don't know is on any rule, you can just add another target to CloudWatch logs. And so that is so useful, so simple, because it's going to use that same input transformer. And any rule you're having some kind of issue, just add a secondary target on the same rule to your CloudWatch logs, and at least you're going to see what is leaving EventBridge. So that is the start. And also, on the step function side, because you've got a whole bunch of SDK integrations, you can actually create some sort of cool testing bits around that, where even in the pathways that you're going down, you can say, well, is this a test? Isn't this a test? Or, do some logging or that kind of thing directly from step functions, just to understand what you're doing. And actually, maybe even step functions pushing data to AppSync, which you could have a sort of live tail of what's going through step functions. Maybe that's an idea. Don't know. Seems possible. Could be. Excellent. Well, Josh, we super appreciate your time on Serverless Office Hours. Just before we do say goodbye, let's talk about next week what we're going to be talking about. I suppose we're sort of event-driven as well. We are talking all about Confluent and AWS. If you aren't aware, Confluent, basically one of the originators of Kafka. So we're going to be diving deep with Joseph Murray from Confluent itself and talking about all the different ways that you can integrate Confluent with AWS. And that's going to include EventBridge pipes and Confluent Connect and Lambda event source mapping. So yeah, lots of ways that you can be able to get your streaming data into AWS. Then also, what did I mention? Yeah, don't forget EDA Day, May the 14th. Josh and I will both be there. So you've had a sneak peek with a little bit of a few things that Josh was talking about. But I think, like me, if you saw the number of slides that are in the presentation and the number you saw today, don't think that if you're not going to get more out of the presentation. It's going to be a lot more. So cool. And then don't forget serverlessland.com, all things to do with serverless and AWS. We've got content pages, a whole bunch of learning guides, and I've been merging some more patterns this morning. The amount of patterns astounds me, how many more infrastructure as code samples. So yes, if you're building things with AppSync, building things with API gateways, certainly have a look at serverlessland.com and specifically the patterns. Loads of good information that you can have over there. But that's it all for today. For same time, same place next week. Looking forward to seeing you. And thanks, Josh, for spending your time on Serverless Office Hours. We always appreciate you dropping your good wisdom.
Thanks for having me. Have a good rest.